In this video, we'll go over a little bit about what a determinant is and how we take a determinant of a 2 by 2 and a 3 by 3 matrix. So briefly, a determinant is a function, you can say, that associates a real number with a matrix. And for those of you who have not taken linear algebra, have not seen matrices, we're just going to concentrate in this class with a 2 by 2 matrix, which is basically organized for us numbers. So for example, it could look like this. Now when I have a 2 by 2, that means that I have two rows. These are the rows like this, and two columns. And so this 2 by 2 is called the size of the matrix. It's 2 by 2. So this is the number of rows, and this determines the number of columns. So in this class, as I mentioned, we'll work with 2 by 2s and 3 by 3s, or determinants of those. So let's do, let's speak in general about the determinant, and then we'll go back and do a couple of examples. So if I'm looking for the determinant of a 2 by 2 matrix, for example, then I'm going to use these straight bars to symbolize determinant. And suppose that I have the determinant then of this matrix, A, B, C, D. For a 2 by 2, this is always going to be A, D minus B, C, meaning you're going to multiply in what is called the diagonal in this direction, and then subtract the multiplication of going in this direction, from the top second column to the bottom. Okay? And then if I have a 3 by 3 is a little bit more involved. I'm going to erase this. So if I have a 3 by 3, let me just write a term of 3 by 3. And again, I use these bars to symbolize that, and then let me put a 3 by 3 matrix here, A, B, C, D, E, F, G, H, I. What I'm going to do, and now if you know other ways of finding a determinant of a 3 by 3, you're welcome to use those. I'm going to show one way of finding it, and there's multiple ways. I'm going to take the first column, this column here, and go component by component. So I'm going to have A, and then I'm going to multiply A times, you see, if I block off everything that touches A, or the row and the column that touches A, I end up with a 2 by 2. So I'll take the determinant of that 2 by 2 that remains. Again, here's A. A is in the first row, so I'll ignore that first row. It is in the first column, so I'll ignore that, and I'm left with E, F, G, H, I. Then I'm going to do minus the next number. In this case is D. And I'll have here everything that touches D. I'll have the determinant of B, C, H, I. And finally plus G, the determinant of B, C, E, F. And that's in general the method to use. So I jumped ahead and wrote this example to save a little bit of time. So let's say that what happens when I take this determinant of this 3 by 3. I would have 1 times the determinant of 1, 3, 0, 1, minus 2 times the determinant of negative 1, 0, 0, 1, plus negative 1 times the determinant of negative 1, 0, 1, 3. And now I can find these numbers. I have 1 times, the determinant here is 1 minus 0, so 1, minus 2 times negative 1 minus 0, minus 1 times negative 3. And that gives me 1 plus 2 plus 3, and that's 6.